In this video, we're going to briefly address a couple of quadratic ideas, additionally, including quadratic regression and intersection of two functions. So some of these ideas we've already touched on before. It's more of a review and practicing things in a different way. So let's say that we have data, and in this case we have the number of donors of a particular blood type, and that's a function of years after 2000. Create a quadratic regression for this data and discuss the goodness of fit. How many donors should we expect in 2015? Okay, well, first off, here's the data. We have years after 2000. They go by twos, reported in 2-year increments. And then the donors are shown here in millions, 1.4, 2.41, 3.16, and so on. And one thing that we might notice is that the trend, first of all, is not linear. In fact, it is quite the opposite. 1.4 to 2.41, that's an increase in a 2-year period of 1.01 million donors. But then the next jump is a little bit less. It's 3.16 minus 2.41 is, let's see, 0.59, 0.69, 0.75. So that change from 1.01, then only a change of 0.75, and then only a change of, let's see, we have a change of 0.58, and then the next change from 2006 to 2008 is 0.22. Well, the change in these rate of changes, we notice that the increase in donors is going down, and here are the change in the donors, the change in the donors over time. So we actually notice that these aren't constant, but they're pretty close to one another. They're at least kind of random. And so that might indicate that if the second difference, the change in the rate of change is somewhat constant, that might be a quadratic fit. So anyway, it tells us that we need to do this, and so I've already entered the data here as usual into L1 and L2. There are my years after 2000. There are the donors in millions. And now I would come over to my y equals, clear out anything I have there. Remember, if we're doing regression, we want to turn plot 1 on. So we'll highlight that. And now we can proceed to do the regression. So we would go to Stat, Calc, and instead of selecting linreg, we would select quadreg for quadratic regression. So the steps are identical. We could hit Enter, and that would produce the values of the equation. So it produces equations of the form y equals a times x squared plus b times x plus c, and then it tells us what the values of a, b, and c are. So in this case, our x is years after 2000, our y is the number of donors. Well, I don't want to calculate this by hand. I don't want to have to write this down. So what I'm going to do is I'm going to go into my y equals, and I'm going to go over to vars. We would go down to statistics, number 5, over to EQ, and then reg EQ. And there we have it. There's the equation in all its glory, negative 0.007 x squared plus 0.4x plus 1.5, and that's the constant. So it gets all the beautiful rounding in there. And now if we went to zoom down to option number 9, that would be zoom stat. And there's the data, and there's the quadratic function. Now we notice that if we were to zoom out, this quadratic is eventually going to start coming back down because the change in the rate of change is negative. The increases are getting smaller and smaller. So we would expect that over time, if we zoomed out, that eventually that rate of change would slow down so much that it would zero out and potentially come back down. Now we don't know for sure. Now we want to know what it's going to be in 2015, so I am going to go over to second graph, and I can just scroll down to year 15 and figure out what that is. So it's 6.05. So I would expect 6.05 million donors, which is still going up in that particular year. And now, so I can look at all those. So second quit, I can look to see that my R squared is really high. It's almost a score of 98%. That's a really good fit. That's if that were your test score, 98%. That's a really good test score. So the fit is strong. We see that.